This video, I'm going to show you on Form 4, Physics, Chapter 2 of Part 3 called Dynamics. Now, in this part of video, Dynamics, you get to learn kinematics and also the force. Yeah, meaning you have you're going to deal with a few things. Velocity and force, the movement and also the force causing that movement. Okay, my previous 2 video is all about kinematics. It's all about movement. Yeah, the 5 equation that you should be very good at it by the time now. So now a new topic called dynamics. So in dynamic, there are 3 things you will get to learn. First, I think I'll put it into table form. Mind map them into 3. 1, 2, 3 branches. First, you get to learn inertia. Inertia is not a quantity. Inertia is a phenomena. Okay, it will normally comes out in your objective questions. Whenever inertia is concerned, it's all about mass. I will talk about mass later. Symbol M, unit kg. Okay, SI unit. Mass. Higher the inertia, higher the mass, or perhaps higher the mass, higher the inertia. That's all about it. Okay, it's a phenomenon. What is this phenomenon about? Maybe I'll put into notes so that it will help you to comprehend it later when you read on your exercise. You've gone through my video doesn't mean that you will get an A. Yeah, you've gone through a video. My video helps you to read your reference text. Okay, so you have some idea what's happening. So, what is inertia? This phenomenon. This phenomenon is all about the object. Huh? What happened to this object? Object will continue. Will continue with what they are doing. Huh? Continue with what they are doing. With what they are doing. Okay, it's not human. It's just that. Is actually to be a scientific, a more exam-based answer would be, this is a phenomena where the object will have a tendency to maintain its state, meaning is it movement, is it a movement, or is it not movement, stationary. Okay, so the key word here would be a tendency to maintain the state. Yeah, you may look at the your reference. Yeah, what are the effects? Let's say for a bus, while you're standing on the bus suddenly stop. What happened? The passenger will lurch forward. Okay, and there are a few more examples. A bicycle, a sudden stop. What happened? It will throw the passenger to the front because the passenger and the bicycle is moving. The bicycle stops, but the human riding on it, riders, doesn't stop. You continue its movement. So the effect of throwing the passenger to the front. Okay. Or there are a stack of book. You pull one of the book in between. What happened? The book will comes out. The rest on top will goes down. Still, yeah, it will stack up. There are a few more examples. Kindly read onto it. Also, distribution of mass. How do you test? A boil or a raw egg, hard boil or a raw egg, yeah, because that's what you will see, yeah, the effect of inertia. Then, because of that, inertia relates to a tendency to maintain state, and this actually helps you to memorize it better or understand it. Would be, this is actually what you call the law of inertia. What is it about? It's actually Newton's first law. Okay, law of inertia is actually Newton's first law. You may equate it to that. Newton's first law in some objective question. You know, Newton first law. There are total 3 laws. Okay, first law is a tendency to maintain its state, meaning an object continues its state as it is unless acted upon by an external force. Meaning an object will continue its movement to the front unless then external force, maybe while an object rolling, a ball rolls to the front, what happened? Frictional force act against it, therefore it will slow down the object, your ball, okay? Or perhaps a ball rolling on the front, there's another force to the left, to right, what happened? Then the ball will not move to the front, it will move to the right, okay? So that's what it means, yeah? Newton's first law is about tendency to maintain its state. It's all about inertia. Higher the mass, higher inertia. As long as mass is involved, then that's inertia. Okay, so second thing you will learn. First thing, if it's unclear, you may go through the reference or text about it. So second thing is called momentum. Now momentum relates mass and velocity. When you have mass and velocity, then that's momentum. So what is that? Momentum, symbol P. Momentum is actually mass, a product of mass, V. Okay, velocity, product of mass. So this is mass, and velocity. Make sure they are in SI unit. So therefore, the unit, okay, the unit for P, momentum, the unit is kg meter per second. Alright? So what's momentum? In order to explain it, for you to better understand it, what is momentum? Momentum is actually the object resistance. It's actually resistance. It's a resistance. Resistance of an object to a change. In a state. Okay, so it's a resistance of an object. So they are. It seems that they are the same, but it is not. Yeah, inertia is a tendency to maintain a state. Momentum is a resistance of an object to a change of its state, a change in the state, in the state. Okay, there are a few more things you need to learn in momentum. There are actually three principles. Okay, there are three principles. They call principle of conservation of momentum. Conservation of momentum. Okay, I will talk about what's that in the next page. Okay, then the last thing you will learn in dynamic, that would be called elasticity. Now in elasticity, you get to learn Hooke's law. Here you have a law called Hooke's law. Okay, here I will talk about Hooke's law in the another page later, but basically what is it? What Hooke's law says? Hooke's law says you have a force measured in Newton, 0. You have distance x measured in meter. Okay, it is always in a linear form. Okay, higher the Newton, where F equals to kx. Okay, k is a constant, which is the gradient. Right, and also you get to learn the energy. Energy store is always the area under the curve, since it's a straight line curve, so therefore it is half Fx. Or it's also total energy store in the spring, yeah, elasticity normally the spring, half kx squared. Okay, or potential energy stored in the spring, that's the last part of it. So this is basically what you learn in dynamic. Okay, let me dive into the second part, momentum, because I've gone through inertia. So in momentum, or I put it as into an example. Yeah, how do you tackle a question on momentum? It is rather straightforward. If you know how to calculate, then you should be able to answer question in regards to momentum. Okay, now say for example, if you play tennis ball or you play squash ball, you have a mass and a wall. Okay, solid wall. Of course, wall is a solid. What happened is you have a ball towards the wall, a ball of mass maybe 0.8 kg. Okay, strike at the wall at the velocity. Okay, moving to the right, velocity is equals to 10 meters per second. Okay, so this is what you need to look at. Yeah, how do I draw this kind of diagram? You need this while you are answering objective question. They give you a scenario, you need to express it into a diagram form. So first, label what is the mass, label what's velocity, make sure you have an arrow, you know it's going to the wall. Okay, now what happened? Velocity, it is a vector quantity, so it will bounce back. Okay, it will bounce back. Go in, then it will bounce. Okay, we assume there's no loss. Okay, I assume there's no loss. The total changes of momentum. The changes of momentum, okay, changes triangle shape of momentum will therefore be the final one. Maybe I'll use P final minus the P initial. Okay, you want to find out the changes, right? You found the final initial. So what happened is, if you were to get into the equation, so the total changes is actually, now the final momentum is to the left, right? So therefore the m remain. This is the final velocity. Okay, now if in the event v is equals to u, meaning the initial is the same as the final velocity, so therefore the final velocity is a negative side to the left. Why is it negative? Because to the left now. The whole system we consider positive is to the right, but when it bounces back it's to the left, so therefore my velocity is negative. Changes, you have negative, so negative. Initial is m, mass, velocity v, okay, to the right, that's why it's positive. So therefore the changes of velocity, if there's no loss, then they will be negative 2mv. Okay, it's just simple. Now if I were to use numbers, then it's so much easier. So what's the initial? I want to find out what's the P momentum. To strike the wall, what's P1 initial? So therefore there will be mass is 0.8, 10 kg meter per second. Number without unit, they are meaningless. So therefore you know it's 8 kg meter per second momentum. Okay. Now, if I were to say, oh yeah, if now for the case v is not equals to u, okay, and therefore my v final when it bounce back is actually the magnitude only is maybe only 6 meter per second. So what's my final momentum? That will be, the mass will not be changed, mass is always the same, only the velocity changes. So the velocity is to the left, so therefore it's negative 6 kg meter per second. So therefore you get 4.8 kg meter per second. Okay. Why is it a negative sign? Because it takes to the left hand side. Because initially we define, this is according to user, you may define positive to the left. Yeah. If positive is to the left, therefore initially this will be reverse the sign. Okay. But normally we define positive is to the right. So therefore it helps you to answer questions and The negative sign for momentum here, it tells you of the direction. Where is it going? Okay. Now, okay, this is just the first part of momentum. You doesn't need to pause this video. You may resume it because later I will let you pause this video and go for exercise. Now, what I've mentioned earlier, we have conservation of momentum. Okay, principle of conservation of momentum. Cut it short. Would be conservation of momentum. The word suggests. What does it mean conservation? It is there's no loss. Okay, or I would say is the total momentum, meaning what it says. It says it will be in paper 2. Normally it says what's the principle of conservation of momentum? It says total momentum conservation, isn't it? So total momentum is constant. Total momentum is constant. How is it possible total momentum constant? When if the force act on it, or perhaps if there's no external force act on it, or if there's no external force like friction. Okay, external force act on it, act on the system, act on. Okay, for example, frictional force. Okay, the total momentum of the system will be constant if there's no external force act on it, or there's no loss of force. Okay, no loss of energy, no loss of force. Okay, so what does conservation momentum says? Okay, a closed system, the sum of external force acting on it will be 0. Okay, so the total momentum is conserved because of that. Well, there are 3 things you get to learn normally in collision. Okay, so 3 branches. 1, 2, 3. First one we call elastic collision. Elastic collision second phenomenon we call inelastic collision. The third one would be explosion. Okay. Now, in order for you to use this conservation of momentum, let's look at elastic collision. Now, for elastic collision, let me give you a scenario. If you have played the Newton cradle before, I hope you know what's Newton cradle. It's a few balls and tick tock, tick tock. Okay, I try to get you a video of it, or maybe you can look for a YouTube video. Newton cradle. Okay, so says you have 1 ball, 2 balls, and mass 1. You have mass 1, mass 2, 2 different masses for ball. Moving to the right, I would say this is my initial U1, and this is U2 to the right. For the case of U2 is greater than U1 is greater than U2, so obviously they will collide. Okay, now obviously they will collide because if you're moving to the right, U1 moving faster than U2 over the same path, what happened? U1 is going to collide with U2. Okay, therefore, after the collision, collision happens, then what happened? They will continue to move over to the right. I would say this is my V1, V2. The mass remain the same, only the final velocity is different. So under this kind of condition, both objects moving. After collision, both objects moves to the right. Then this would be one of example for elastic collision. So for elastic collision, both objects moves. So the equation would be how? So therefore, the total momentum over left hand side should be the same as with total collision over the right hand side. So therefore, based on this reaction, therefore there will be m1 u1 momentum, first one, plus m2 u2 will therefore be equal to m1 v1 is final velocity plus m2 v2, depending on what the question asks. Okay, if they ask for final velocity, then you just substitute all the value. The mass before and after should be the same. Then you just substitute and rearrange them, then you will be able to find out the answer. Now, second thing about elastic collision, something special is the total kinetic, the kinetic energy is also conserved, it's also constant before and after. Okay. Well, what's that? For kinetic energy that will be half m1 u1 squared plus half m2 u2 squared is equals to half m1 v1 squared plus half m2 v2 squared. Okay, right? Now, in this case, for SPM, this is what you need to know, and this is the condition you should consider. Of course, you may say, oh, what happened when mass 2 is more than mass 1? Okay, then maybe it will bounce. Okay, for that condition, you may consider. Okay, so what you have learned in SPM is not the full set of all unit conservation momentum, because here we never mention what's the mass of M1 and M2. They never let you know what happened when, for this condition, U1 greater than U2. What happened when my mass 2 is greater than M1? Sometimes we just bounce back. Okay, you'll move in other direction. Okay, for this case, M1 I think is comparable, or perhaps comparable to M2. They are almost the same. Okay, M1 and M2 is like a bicycle with another bigger bicycle of the same class. It's not that a bicycle with a lorry, then it wouldn't expect both of them will move over the same direction. Okay, for this case, maybe I want to stress here is that the M1, M1 is very close to M2. Okay, in Form 5 SPM, they never consider cases like what happened when M2 is greater than M1, or maybe M1 is greater than M2. But normally, the momentum will be different, right? It's all about momentum. Okay, so you just need to know for elastic collision, total momentum is the same, total kinetic energy is the same. That's all you need to know. Yeah, the details of it, you will get to learn it sometimes later in A-level, SAM, or pre-U program. Yeah, like that. Okay, you may read through the some textbook or reference on this, or you may look for pre-U physics or degree, first year degree textbook on momentum. You will get to learn a few more examples. Okay, but for SPM wise, yeah, this video is meant for only SPM. Okay, so this is the condition you need to know. First, elastic collision, you know the momentum before, momentum after is the same. Second thing, the kinetic energy before and after, they are supposed to be the same. That's why you have equal sign, right? Okay. Next, what about inelastic? Inelastic is even easier. What happened? Because inelastic collision, it will be same two object, mass 1, mass 2, maybe mass 2 is not moving, okay? Moving to the right, U1, maybe moving, maybe not moving, U2, okay? Or I'll say, oh, maybe I'll put it as easier for you to comprehend it. U2 is basically equal to 0, not moving. After the collision, what happened? Both the objects sticks together and move over the same direction. Okay? After the collision, they stick together, M1, M2, both of them moving over the same direction, over the same velocity. They stick together. So most probably, maybe M2, the mass is smaller, maybe it's smaller, or M2 is not necessarily smaller, but it's not moving. Okay, it depends. Okay, depends. Okay, so what happened? The condition, I would say, maybe my U2 is equal to 0. Okay, or my M2 is so far by much less than M1. Then M1 will come to, it will stick moving together. Okay, so here only momentum is the same. Okay, before, this is what I have before collision. After collision, this is what it is. So the equation, I think the explosion part, I think I will just erase it off so that it won't be so confusing later. Okay. Okay. Right. So what happened here? The inertia M1 U1 plus M2 U2. This is the inertia equals to M1 plus M2 because they stick together with the same velocity. Okay, so this is what you need to know. They stick together, M1 plus M2 to the right. This is what they call inelastic collision. Now what happened in elastic collision? Let's say two cars collide to each other. What happened? The metal and the metal will smash together, and the metal will have collision with another metal, and you have frictional force between the metal, and sometimes you have a fire comes out from it. At the same time, the braking system from the second car, yeah, you have a brakes. What happened? You have two tire, the tire squeeze on the floor. You have the track of the rail, the track of the tire, the car will be able to see from the road. So that is a loss of energy from kinetic energy. So this is what happens when two cars comes together. They collide with each other, and therefore there's a loss of energy. And the kinetic energy is not. Kinetic energy is not constant. It's not constant anymore because you have the effect of loss of heat. Okay, it's not conserved. Okay, so this is what you have. Okay, you may pause this video and look for the relevant questions, 8 to 10 questions on elastic and inelastic collision, as well as with inertia. Okay, so the last one, yeah, as I mentioned, maybe I put it to the right here, right side. The last one just now, continue from there, is explosion. Example explosion. Easier way for you to comprehend would be left. I have two cars, two trolley, and then I have a wedge, a triangular look object. Okay, just rest on it in the middle. Then have a hammer. I use a hammer. I bang on it. What happened? Pow! Tuk tuk. Tuk tuk. Bang on it. What happened? Next moment you will find that one car will be moving to the right. One car to the left, sorry, will be moving to the right, right? And then your triangle down here. Right now. Yeah, bang! Then explosion. So this is what you have, okay? Object may be 1, this is my M1, this is my M2, okay? After the explosion, they move their own way. So initially, before that, both object is stationary, so therefore initially 0. After that, this is M1, this is M2. Okay? Depending on how you want to have positive, okay? Where do you want to put in positive? So, but the overall, that will be M1 V1 plus M2 V2. Okay? Depending on which direction you want to define positive. Okay? So this is what you have. Before, after. Before is 0, that's nothing movement. After, yeah. This is the same thing happen in a gun explosion. Bam! The bullet travel to the right, and then the shell go to the left, or you have the recoil force. Okay? And this is one of those standard thing you get to learn: motion and force, and momentum. Because I believe next video you get to learn some other things. You may want to go to a reference or exercise, chapter by chapter exercise, and then look for example exercise. If I were you, you will look for those experiment example. They give you a solution. There's some numbers to substitute and then to calculate. Yeah, you want to calculate yourself, not just by looking at the working and you thought you know what is it. No, you need to calculate them yourself. Okay, so maybe I'll put a few more things here. The total moment here, the total momentum is conserved. Okay, again because it's conservation of momentum. So over here, what happened? It is that if you were to rearrange this here, what we have here is M1 V1 is equals to, put the other side, is a negative of M2 V2. Okay, so maybe I define positive is to the left. Okay, so therefore I know that the M2 moving object is to the right because it's negative side. It's opposed to what I define positive. Okay, it's not necessary that you need to define positive is in a positive direction. Okay, there are quite a lot of examples. Okay, all you need to do is pause this video and go through the exercise. Okay, go through the exercise. Look at it as a system, and then where it goes after that. Then for conservation of momentum, there are some application. You need to read through the application because it comes out in a paper 3 sometimes, or 2. Okay, a rocket, how does it work? Okay, and also a jet engine. Yeah, how the air being sucked into it, combustion, and then explosion, high-speed exhaust, and then those exercise. Okay, I think that's all for this video. I'll try to keep it short. I hope you like. Press on the thumbs up button. It means that you like my video. It costs you nothing, but it is an encouragement for me to make more videos in the future. The rule is always the same. You go to my video, you need to read on your own reference, and then you try those example, 8 to 10 questions cater for this video: inertia and momentum. Okay, stay tuned to my next video. Thank you.